start.
Okay, so on the airplane problem, first thing, when we're drawing this, we have to understand the bearings. You're flying at a heading of 110 degrees north, clockwise from north, and an airplane that cruises at 125 knots. So when we draw this heading, 110 degrees from north. So when you think about an angle, this would be 90. And then how much further do I have to go until I hit 110?
10 degrees, or 20 degrees.
20 degrees. So then the airplane's down here flying at this vector, where you know this entire angle is 110. We just described how this little angle, though, is negative 20. Negative that direction, if you want to call it, from the x-axis. So theta could be described as 340. Because 360 in a full circle minus the 20. So 360 minus that 20 degrees. So we know theta here is 340 degrees. That's for the airplane's path they're trying to fly. Question, how are we getting that theta value? That was the hardest thing for third hour we went over. So 20 degrees here, because it's 20 degrees past 90 to get the 110.
Why do we need
110 degrees. Because when we use our vectors, we have to write it in terms of theta, not in terms of the bearing. So 110 is this angle, right? You can't use that in the problem as theta, because 110 is from north. Theta is always from the positive x-axis. So either a positive 340, or you could use a negative 20. Those are coterminal angles. Daphne, okay with that?
Mm-hmm.
That is just for the plane, and we know that's going at 125 knots. Then we have the wind. The wind is 25 knots at 30 degrees clockwise from north. So 30 degrees, so this would be 30 degrees here, and we're going 25 knots. 30 degrees should not be theta though. What's theta going to be? Yeah, 60, because that angle would be theta. So 60 and the 30 gives us the 90. So we know theta here is 60. So finding those parts of your vectors is the first task. Draw it, make sure you know your magnitudes, and then make sure you know theta from the given bearings. Whatever the situation is given, can you find the actual theta value from the positive x-axis? Either a negative or the positive theta value. So now we can write the vector for each one of these. So let's write the planes vector, and we can write it in some of the other problems have you write it in this form. It's our magnitude, so we call this P, the magnitude of P times cosine theta I plus sine theta j. So I know there's at least one other problem that has you write in this format. We're using our magnitude and our theta to write the vector. This is that linear combination form. The magnitude would be the scalar, the cosine of theta, and the sine theta gives us that direction for that unit circle. It's a change in x and change in y for a unit vector. So in this, our magnitude is what in the problem? Yeah, give it a 125. Cosine of theta, that's why we had to find theta, so you can either use negative 20 or you could use the positive 340. And then sine 340 j. Questions on how we're finding the vector, the linear combination for the planes vector? It's all the green. Now I could write it for the wind then. Same format, 25 knots, cosine of theta, which is 60, I plus sine 60 j.
Why are they called 340?
That's the same vector.
Oh, okay.
This is just the horizontal movement. This is the vertical movement.
Okay, so if we use negative 20, it's sine negative 20.
It'd be the same thing though, right? Cosine of 340, think about the unit circle, our trick in chapter 4. Cosine of 340 is telling us our horizontal movement when we're on the unit circle. This is just the horizontal movement of that triangle. This is just the vertical movement when we're on the unit circle, unit vector. What's the vertical movement for that vector if it's a unit vector? We're going to multiply that by a scalar to give it its length. And questions on either of those two vectors? That's just what the problem's given. Take in the vectors and put them as given information in linear combination form. The problem is trying to figure out what happens if the plane is flying like this and there's a wind going like this. What's going to happen to the plane? The angle is going to change more towards upwards or towards the x-axis, right? So it's going to be pushed this way. Do you think the speed is going to get faster or slower if the wind's pushing like this?
Slower.
Probably a little slower too, right? So if I'm drawing it, I'll draw it somewhere over here. I don't know really where it's at. I drew this one really long. It's probably not this long. This vector is probably, it's only 25 knots compared to 125. So you think about if I'm drawn to scale, it's a little bit shorter. So it's going to be something like this. And then I can move that wind's vector, which probably is more like right here. I'll move it here. So that's the wind's vector. Let me erase that top of it so I'm sure you see it's a little bit more to scale. So this is still the wind over here. We're just moving this vector here. We have the parallelogram law, so now I'm adding these two vectors. Notice the arrows on these vectors so you know the direction, plane, wind. We're adding these two vectors to have the result. That's what the problem's asking for. So the result is going to be found by taking the plane's vector and adding the wind's vector. We have the plane's vector down here, which is 125 cosine 340 I plus 125 sine 340 j. And then we're going to add to that the wind's vector, which is 25 cosine 60 I plus 25 sine 60 j. Notice I distributed it in the magnitude. I distributed it in that scalar. So both the horizontal and the vertical now have the scalar attached to it. So now we can actually add those together. Make sure you're in degree mode. Always good to check that. So 125 cosine of 340. 125 cosine of 340. And I'm going to add to that the 25 cosine 60. 129.96 I. So that's just my horizontal movement. I multiply those together. Do the same thing for our change in y's, our sine values. We're getting a negative 21.1. So that negative y value tells me we are going to be in that fourth quadrant. So I am drawing this in the fourth quadrant. I'm drawing a little accurate. I wasn't sure if it'd be here or above. It'd be somewhere over here. But because the negative y value is going right and down. So this is our resultant vector. The problem, though, is asking for our magnitude and our angle. So magnitude, square root of 129.96 squared plus that 21.1 squared. Square negative is positive. So and square root. I'm getting 131.66 knots. Actually include units. There's the magnitude. So it actually is going faster. Notice that? If you look at the angle of the wind is going this way, so it is going to push it a little bit and actually go faster. We're quite sure what's going to happen. This shows us that knots is actually faster 125, so that wind is actually a little behind us, so it's actually going to push us. Then to find the angle, how do we find the angle? How do you find the angle?
You just use trig.
Well, what trig do you want to use here? Yeah, why the tangent?
Because it's super easy. You just do opposite overages.
Yeah, because we're given the opposite and adjacent. Do you visualize this as a triangle?
Yeah.
This right here is this black triangle. It's 129.96 right and down 21.1. So we're given the opposite and adjacent. We're trying to find, we'll find this angle then. So inverse tangent of negative 21.1 over 129.96. You want to already punch that in? Negative 9.22 degrees. That's this angle right here. How else could we write that angle? Or how should we write this angle? Yeah, AJ?
For negative 9.2, you just add the 90 degrees so that it's a bearing in relation to north.
Yeah, because we want to go from north, how we're saying clockwise from north. So from north is exactly what AJ said, the whole 90 degrees plus that angle. So our bearing from north, it's 99.22 degrees. So there would be the bearing. Questions on that problem?
So you just ignore the negative
Why is there a negative here?
because it's going down from the
Fourth
x-axis.
quadrant going down from the x-axis. That's how we write theta, right? When we write this bearing from north, that's describing how we're going negative. So the wording's telling us the direction we're going, not the sign.
But you could have gone 99 the other way.
We could have gone 99 this way.
Like, if you just say from north 99 degrees,
So,
couldn't you go the other way?
Because of the context, we're dealing with aviation. Every problem we've discussed with aviation has always been what? Clockwise from north. So because the context, we know
So
that.
it'd be 75.
Yep.
Two
Any other questions? Well, I have another problem on the answer sheet you can do. So you can try it and then I'll look at it. Okay?
Or 19.
We'll do other questions. Any other questions on this problem? Okay. Daphne, you want to stop that?
First of all, on there.